Good morning. It is 11 o'clock on September 12th, 2022, and it's a beautiful early full day here. And I am Jana Hexter, and I'm delighted to welcome you to Expanding the Integrated Weed Management Toolbox Approaches for Maryland and Mid-Atlantic Vegetable Production with Dwayne Joseph. And Dwayne, if you could move the next slide, please. A recording of this webinar is being made right now and will be available to you probably in about a week at the link below. And anyone who is registered for this webinar will receive a copy to the webinar recording when it's available. So if you know someone that's missed it and would like to see the recording, just tell them to sign up for the webinar, and then they will receive it. Next slide, please. We love to have questions. We have several slots in this time set aside for questions, but it's hard for me to keep track of that in the chat. So what we'd like to ask you to do is to use the Q&A feature. So if you put your mouse over your screen, you should see a black bar that comes up either at the top or the bottom. And in there, there's a box that says Q&A with two like squares in it. And if you click on there, you can ask a question. You can also do so anonymously. So if you want to feel more comfortable doing that, you can ask an anonymous question. And that way it's easier for me to keep track of which questions have been asked, and then I can mark them as answered. And sometimes people ask the same question, so it's a more efficient way for us to do that. And next slide, please. I am delighted to introduce Dwayne Joseph. He is an agriculture and food systems educator with the University of Maryland Extension. He has an MS and PhD in weed science from Clemson University. His current research focuses on evaluating integrated weed management plans for vegetable production in Maryland, with a special interest in conservation tillage, strip till and no-till, cover cropping, and organic practices. And I can tell you, Dwayne loves his work because he told me he went to a cover cropping field day yesterday, and it was a lot of fun. So it didn't feel like working on the weekend. So before we dive into Dwayne's presentation, I have a question for Dwayne, which is, what is the best advice that he's received that's empowered you to achieve your professional goals?
So how much time do we have? I was thinking about that. So I got this advice way early when I was still an undergrad, actually. So I wanted to go to professional school. Didn't have the money to. Decided to went to go to grad school. Did some undergraduate research at LSU and down in Baton Rouge, Louisiana. And that summer I worked with one of the grad students, and I was asking her, like, what advice does she have for me when it comes to, like, finding a good professor, finding somebody, a good mentor to work with. And she told me that first, you don't want to get, and again, that would be some advice I would give to if there's anybody in here that's undergrad trying to get into grad school. She told me to don't pick someone who's like an assistant professor that just started out, because he will have you do all of his work, basically, because he'll have a bunch of work and he'll have you do all of his work because he's trying to make tenure. And she also told me don't get a full professor, because he will be very demanding and he'll want you to do a lot of stuff and he'll never have time for you, basically. So she told me to find somebody who's an associate professor, somebody who's right, almost like an assistant, almost about to make tenure. So I think that was really good advice, and that kind of helped me figure out what mentor to pick, because that's a big decision when it comes to going to grad school, whoever you work under. So out of all the advice I've gotten, I think that one really helped a lot.
Oh, wonderful. Thank you. And thank you for sharing that. So, all right. So with that, we have a couple of questions to ask, and I will just start that poll. Oh, there you go. And it's right there. So I think there's just two questions here, and this helps for Dwayne to know who's on the call and what level of knowledge people have, so it helps engage the presentation. So if you could just take a moment to answer that. I've been told that some people with iPads have problems seeing these polls sometimes. So if it's not showing up on your device, it might be that you have a particular configuration that's being problematic at the moment. Great. All right. And I will end the poll. Oh, got a couple more people come in. There we go. Great. Okay, and share the results. So how knowledgeable are people about biosolarization? We have a couple of people who are very knowledgeable, but most people fall into the slightly and somewhat, and a couple of people who are not knowledgeable at all. And then how knowledgeable are people about cover crops? And same kind of same ratio, except we have a couple of experts in the house on cover cropping. So, all right. So with that, I will turn it over to Dwayne, and we will be having some Q&As. So feel free to put your questions in the Q&A box, and we'll take some breaks along the presentation to answer those questions. All right, there we go.
There we go. Seeing me, Yana?
Yes, we can see
me?
it. That
Okay,
looks
good.
great. Yep, it looks
Awesome.
great.
Awesome. So, this is just well, let me kind of introduce myself. My name is Dwayne Joseph, like Yana said. I'm a ag extension educator here at the University of Maryland. I'm in Kent County, Maryland. That's, beautiful Kent County right across the bridge. We have a lot of beaches and bays. That's just, it's a plug, basically. It's in my contract. I have to put that out there. So just a little introduction into, what an outline basically of what we'll be talking about today. So I have two field studies that are ongoing that I'll kind of talk to you about. I'll do an intro. I'll introduce my plasticulture / cover crop study, which we're doing. Then we're going to pause for some questions if anybody has any. Then I'll go into the field study of a biosolarization project, which is in the first year of working, and I'll give a conclusion and summary, and then after that we'll field any questions. So when I do these types of presentations, I always have expectations. So my main expectation for this project, for this presentation today, is to kind of get you guys acquainted with some of the IPM research that we have being performed at the University of Maryland. When I first came here, before I came here, I always thought of, University of Maryland being in this, metropolitan area, not, close to DC, not having much of a ag aspect, but we're, as a flagship for Maryland, we have the main ag obligations as a land grant to Maryland. So we have a lot of ag work going on at the University of Maryland here on the eastern shore, over in central and also western Maryland. We have a lot of, I think, about 5 different ag research stations. And also with that information that, I'll give you, hopefully you guys, assess the utility of whatever techniques that I'll bring forth to you today, and probably, use it as implementation in your IPM plan, or, just for the general knowledge, basically. So keeping in the theme of toolboxes, so I have this funny story I'll give you guys. So couple weeks ago, I think 2-3 weeks ago, my family was out of town. My wife's SUV had a little noise, basically. So for some reason, I couldn't figure out what the noise was. So I brought it to the dealership. They took a look at it, gave me a call. Mr. Joseph, we have this issue wrong with your car. So I was like, okay, cool. How much is it to fix it? $600. And I was like, $600. And I'm a little familiar with, I know my way around vehicles. So I was like, that's okay. I'll come pick up my car. Picked up my car, bought the part. The part was about $60-70. And since I've done it before, I was like, okay, I'll fix this. This should be really easy. But I've never really worked on my wife's SUV before. Got the part. Had a Sunday, you know, blocked out about an hour to get that work done. Saturday, did the work, started working, couldn't get the couldn't get there was this nut, just couldn't get it off. Wasn't enough space, wasn't enough clearance. I tried everything. I almost tripped the nut, basically, the bolt actually, sorry. Um, it's kind of embarrassing, but if I could cry, I would cry. It was really hard. 1, 2, 3, 4 hours passed, basically. Couldn't get that bolt off. So I went to AutoZone, got there's this they loan tools basically. So I loaned out a tool, got it in there, had the right tool, took me about 20 minutes to get it off, put it back on, half an hour, work was done. But the reason it took me so long to get it done, and I almost stripped the bolt, and that would be a whole nother issue if I stripped that bolt, was because I didn't have the right tools. So coming into this presentation, I was like, it makes sense. You must have the right tools. And like Yana said yesterday, I was attending this cover crop workshop, and I was speaking to this gentleman, and he was, kind of going over, the reasons why we have this big issue with selection of herbicide resistance because of what happened in the 90s with the onset of glyphosate and all farmers just using glyphosate on everything. I'm basically not using these other tools in the toolbox. So with our research, we try to basically use all those tools, like integrated weed management, integrated pest management, is the use of, integrating, like it says, it's self-explanatory. We use all these different tools and, in our toolbox. So that's my little spiel on toolboxes. So like I said earlier, so an integrated weed management program. So what exactly is integrated weed management? Again, that ties into IPM. An integrated weed management program basically involves the use of a combination of tools. So we have cultural tools, mechanical, biological, chemical, and they all use to deploy a holistic and synergistic weed management system. So at the moment, there's a great need for designing integrated weed management approaches and programs, and that's largely because of the herbicide resistant weeds and the selection for those. So let's look at in-row plasticulture, in-row, I like to call it in-row weed control. So we see all these benefits of, using plastic. But one of the greatest benefits of growing crops on plastic is early production. And that's because the mulch kind of raises the temperature, which helps plants grow more quickly and mature much earlier. So for example, if we look at spring vegetables that are grown on plastic, they can be harvested from about a week to about 3 weeks earlier than, just bare ground vegetables. So plasticulture systems can give us and give producers such as, let's say, fresh market tomato growers, the ability to achieve earlier harvest and increase yields, and also just give them a greater, better quality fruit. So let's look at another technique, cover cropping, between row. I like to call it control or management. So we have a list of benefits from cover crops. They prevent soil erosion, they improve soil tilth, they add carbon to the soil, they suppress weeds, they improve the availability of soil water, they break pest cycles, along with a bunch of other stuff. But let's kind of hone in on, suppressing weeds. Like Yana said, I'm trained as a weed scientist, so my focus is always on, how can we suppress weeds? How can we manage weeds? So, cover crops, they mainly suppress or they mainly manage weeds in two different ways. So first, there's light interception. And what that is that, that biomass, that cover crop residue, it covers the soil and the soil surface, and it kind of blocks basically the sunlight and that stimuli from the sun for weed seed to germinate. And also cover crop can employ allelopathy. So some cover crops produce allelochemicals either in their roots or the shoot exudates. And those, when they are released into the soil, they kind of inhibit weed seed germination and also growth. So as I was speaking I was speaking to this vegetable farmer yesterday, and he kind of, strengthened, the issues when it comes to, working with plastic. One of the main issues is that, with plastic culture vegetable system, there are these wide row spacings. And what would happen with, these large areas between your rows, your plastic rows, is you'd have these large areas of bare ground. And when you have bare ground, what would happen is, you're just inviting weeds to come between those plastic mulch rows. So that's the main problem we saw when it come to using plastic culture in vegetable systems. So when these weeds come up, what they do is, they compete with the crop, they interfere with harvest, they impede herbicide sprays. And so to try kind of achieve a season-long weed control in plastic systems, the growers really rely a lot on multiple herbicide applications because, cultivation is not really practical. It can be done, but, repeated cultivation, rips the plastic. And there's a certain time during the season, it's not really feasible. It becomes expensive. And, those rips in the plastic kind of reduces the efficacy basically of weed control of the plastic. Also, the application of herbicides after planting are more difficult for vegetable growers. And that's because, there's limited options, limited herbicides that are registered in vegetables. And also there's a risk that comes with, injuring the crop by those herbicides. So a more eco-friendly solution for between row weed control may be, applying using a terminated cover crop or a living mulch, and to put those in between those mulch rows. So it's less expensive. It's also less labor intensive than, applying post herbicides and applications. And again, that goes back to, the reason I said before, there's not really much herbicides that are registered to be applied in vegetable systems. So if that, I'll pivot into talk about this spring seeded cover crop plastic culture study, which we have going on. This is the second year of this study. This study is PI'd by a colleague of mine, Kurt Vollmer. He's the extension weed scientist over the whole of Maryland. And I'm a co-PI along with some others on this study. So the goal of our study is to use a spring seeded grass cover crop opposed to something that's applied in the fall. And the reason for using a spring seeded is to give, the farmer more flexibility when it comes to using a cover crop. And also to look at reducing herbicide use while eliminating the need for residual mechanical or manual weed control tactics. So for our objectives, we are evaluating the effects of our cover crops on weed suppression, also reducing herbicide applications, and on insect populations. So this is a multi-state, multi-crop study. I've been working with peppers at Central Maryland. Kurt Vollmer is working with watermelons, and he's at Wyrick, and that's on the Delmarva Peninsula or the eastern shore of Maryland. And also we have Thierry Benson-Court. He's up in New Jersey at Rutgers, and he's working with cucumbers and tomatoes. So for our study design, we have we're looking at 3 treatments basically. So we have a spring oat treatment only. That's a spring applied seeded cover crop. We also have cereal rye. And then we have a mixture of both at half the rate, oats plus rye. And then we have our control, which doesn't have any cover crops in it. We had 3 termination types. We terminated with paraquat or bromoxone. We also terminated with clefaidim or Selectmax, and some of the treatments we just rolled. And our treatments was we had a split plot design, a randomized complete block design. And also for our last variable, we had residual. So half of the plots, half of those subplots, we added a residual of a tank mix of formicefin and metolachlor, and that's basically reflex and dual magnum. And for half of those subplots, we didn't have any residual. So for data collection, so we collected, we look at cover crop for our responses, cover crop canopy and the biomass. We also looked at weed species and abundance. We looked at insect species. So there's an insect aspect to this study, which I won't hit on because, like I said, I'll just hit on the weed aspect of it. And also we had visual weed control ratings. We looked at the crop growth, and finally we looked at yield. So I will just go over the results of my specific project, and that's with peppers, bell peppers. But when we compiled all our information, we basically got kind of the same responses in all the crops, the watermelon, the cucumbers, and also in the tomatoes. So let me set up this graph here. So on the y-axis, we have so we're looking at the cover crop biomass, and that's at termination. So on the y-axis, we have pounds per acre. And on our x-axis, oh, here we go. On our x-axis, we have our cover crop treatment. So oats, rye, and rye plus oats. So as we expected, we found that, at termination, that oats had the highest biomass. And again, we chose, like, if you could kind of rewind to the reason we looked at cover crops, and the two main methods that cover crops control weeds or manage weeds. Look at biomass. So basically the ability to block that soil, that sunlight from hitting the soil and causing germination. So that's why we chose spring oats, because of its ability to, just put on as much biomass right before we could terminate it. So that was kind of expected with the oats, the spring oats having way more biomass. Also, it's expected with the rye. Like I said, the other method of control was allelopathy, and rye has been known, it's been well documented to be allelopathic. So that's why we chose rye. So we had oats and rye, one for its ability to produce biomass, and one for its allelopathic ability. Again, let me set up this graph. So we're looking at different cover crop termination methods here. So on the x-axis, we have our termination times, our assessment time, sorry. So we have 5 weeks after transplant, 7, 9, and 11 weeks after transplant. And on our y-axis, we have weed control. So this was just basically visual weed control. So 0 means no weed control, and 100 means complete weed control. So 100 means there were no weeds in our plots. So what we see here is that termination with paraquat or gramoxone offered the best weed control. So if we look at, gramoxone, it's a non-selective burn down herbicide. So it would basically have a better activity than Selectmax, which was the clethodim, which is only a grass herbicide. So when we look at our termination 5 weeks after treatment, we see that, when we look at 7, 9, and 11 weeks, excuse me, after treatment, we found that we got almost 100% weed control compared to those plots that were rolled. So paraquat was basically way better when it comes to terminating our cover crop. Excuse me. Have a drink of water. Sorry about that. Okay, so let's look at residual herbicide treatments. So again, on the x-axis, we have weed control visual 0 to 100, and on our x, we have our visual assessment times. So with a residual herbicide application, we saw that it increased weed control at all our rating times. So we also saw that we got about 68% increase in weed control when using a residual at 9 and 11 weeks versus when we didn't use a residual. And again, that's that was one of the main reasons why, we added that residual in there to see, if we would be able to get full season control with that residual base versus not having that residual. So let's look at cover crop species. So cover crop presence increase weed control compared to no cover crops. So if we look at this, so basically we see that, any species of cover crop increase our weed control by more than 100% at all rating times when we compared it to subplots without any cover crop. If we can kind of, glean any more information out of this graph, we see that, oats, basically the biomass breaks down over time, and that leads to a steep decline in weed control compared to the rye. So if we look here, oats would be the yellow bars. Like I said, we're just trying to glean something out of this. A lot of them are not significantly different, but if we look, we could see, that steep drop off compared to rye would be those red bars where, it's a less gradual drop off. And that would basically be because, rye at first, like I said, is the main mechanism of control with rye kind of comes with allelopathy. So at first, it wouldn't have that high control because it hasn't really broken down and those chemicals hasn't been released. But as we get further down in the season, we see rye does a little better when it comes to weed control compared to the oats, which, would have that biomass, that residue on the surface, but would eventually break down quicker, causing those weeds to come up in between. So let's look at yield, our pepper yield. So we have two graphs here. First graph on the Y, we have pepper yield in response to cover crop. So that's just our yield in pounds per acre. And on the X, we have, again, our treatments, cover crop treatments. And this second graph over here, we just looked at the amount of fruit that was produced by each plant, in each treatment, sorry. And on the X, we have just the number per acre of pepper plants, pepper fruits, sorry, produced. And then again, on the X, we have our different treatments. So what we can take over here is that we see that, yield in rye plus oats was significantly greater than just rye alone. So basically we found that, both the amount of peppers produced and also just the weight, the yield produced, we found that treatments if that was mixed rye plus oats, we had significantly more better yield basically compared to rye alone. So just to wrap up this study, so one of our main issues with our first year of the study, which we kind of try to remedy in the second year, is that, if you look on the corners here, we had some issues getting really close to the plastic. So we had a lot of weed control escapes right on the edge of our plastic here. And that could be, for a number of reasons. We found that, the operator, the guy who was riding the tractor, didn't want to get as close to that plastic as possible when it comes to when he had to terminate and also put down the residual. So that could be an issue. Also, the roller crimper didn't get as tight to that plastic as possible, again, because kind of scared of ripping it. So we tried to remedy that this year, and we got a little better control on the plastic. We got a little better establishment of our cover crop, and also we got a lot better control on those shoulders. So, moving forward, that would be one of the recommendations, which we try to, figure out if we have any farmers kind of adopting this technique, basically. So all in all, if we look at the summary, kind of putting everything together, We found that cover crop presence increased pepper yield, both the amount of fruit and the weight, and that's versus no cover crop. Also, we found that termination with paraquat or gramoxone offered the best weed control. Also, an application of a residual basically positively influenced weed control versus those subplots that didn't have a residual in them. Also, we found a synergistic effect of mixing the cereal rye with the spring oats on the yield, and basically, again, that goes back to putting those two methods of weed control together. And also, we can positively kind of refer or tell, give a positive report when it comes to using this technique as a integrated weed management options, especially in plasticulture vegetable systems. So if that, will take a break for any questions. Yana?
Yeah, we have one question, which I don't think you answered. Does the allelopathy of cover crops inhibit the crop, or do you have to choose the right cover crop?
That's a good question. So from what the research has shown is that they don't. Or if they do, it's not a significant decrease in yield, basically. So from all the research, it's from the research which you have there, especially with rye, cereal rye, that allelopathy doesn't affect the crop significantly.
We have one more question. The seeding rates for rye and oats singly are higher than documented literature. Do you recommend using the rates you used for better control, especially without herbicides?
Yeah, exactly. So we use a little higher rate because, like I said, we needed to get, I didn't mention, we broadcasted it. So we didn't, I guess with broadcast, you have to use a higher rate. Basically, we didn't drill it. So that's why that explains our higher rate. And also, we did some preliminary research, and that was the rate we used that got the best control when we did our first, our preliminary study. So we went with that rate.
And another question came in here from Daniel Strum. What is the total cost of cover crops with herbicides versus herbicides only?
What was it? Could you repeat that? Sorry.
Yes, it's a question about cost. So what is the total cost of cover crops with herbicides versus herbicides only?
Cost?
Mm-hmm.
Oh, okay. What's the total cost of cover crops with herbicides versus cover crops only? We didn't do economic analysis on that, but I would think that the cost with adding the herbicide would be a little more costly. But like I said, we also had those we had those treatments where we didn't add any herbicides, and these didn't do as good as those with the herbicides. So yeah, the cost with herbicides would be a little greater because, again, you have to put on the added cost of herbicides and also gas when you get out there and spray it. But like I said, we rolled it without any herbicide, and also we had treatments without residuals, but these didn't do as good as those with the herbicides.
Right. Okay. And I think Daniel's question was comparing that to herbicides only, but you didn't do that. You didn't.
Oh, with herbicides only. Oh no, we never, and we didn't do that. One, and two, with herbicides only, when it comes to, there's certain, because of like I said earlier, there's not many registered herbicides, especially in vegetables. And when you use plastic, it gets even less. So especially when it comes to post-applied herbicides, it's really, you could only, I think, probably glyphosate and Sandia. So yeah, it's really, really limited what you could apply.
Great. Thank you. Well, those are the questions that we have so far. And so I know you've got more to share.
Okay. So going on, so This is, and again, I forgot to mention that the first project was a NIFA funded project. This one is also a NIFA funded project. This one is in the first year. So, it's really fresh. We have some raw data. Just did the last weed assessments last week. So I have some raw data that well, I can't, it's not analyzed basically. So I could just give you guys some of, the observations so far. So there won't be any results with this study, but I just go ahead and kind of present it to you. So biosolarization. So this is basically a soil disinfection technique, and it's a hybrid of solarization and anaerobic soil disinfection. So this technique involves we add in an organic material into the soil, and that's prior to passive solar heating. So from what the research, the literature has shown is that some of this work, a lot of the work has been done over at UC Davis. And what they found is that when they used tomato byproducts, or tomato pomace as we call it, that they got really good control or really good at inactivation of weed seeds. But for some reason, we just couldn't source any tomato pomace over on the east, in the mid-Atlantic area, and also along the East Coast. I think probably New York was a little too far for us to go to get some. So we kind of, because we're trying to make it, something that's applicable to our farmers in our area. So we kind of used whatever pomace that we could find. And again, pomace is basically just the byproducts of fruit, what's the word I'm looking for? Fruit use, basically, for lack of a better word. So what it is we went to a vinery, and what they did was they gave us all they used tomato culls and whatever they had left over after they processed it, after they squeezed it. Also, we did the same for apples. So this is this picture. This is the grape pomace after it's dried right before we applied it to the soil. And this is the apple pomace right before we applied it to the soil. So we get it in the fall, we dry it, and then we shred it up, and then we store it for the spring. And what we do is we apply to the soil in strips in the row, because it's basically in row weed control. It's kind of like with plastic, with plastic you get that in row weed control. And again, it goes back to having that integrated approach, you kind of separate the in row weed control versus the between row weed control. So we put it on the soil, cover it with clear plastic tarp to facilitate solarization. We run drip tape, keep the soil really moist, because that's what gets those phytochemicals to be broken down and released into the soil. And so basically, and then after that, we let the sun do it work. So the sun comes in, heats it up, kind of has a greenhouse effect, and gets that soil warm, releases a little chemicals into the soil, disinfects the soil basically. And after 10 days of biosolarization, we remove the plastic mulch and we remediate the soil for about 7 days before we transplant. So we found that some benefits of biosolarization is that it's compatible with organic farming. So a lot of our organic farmers, they couldn't find ways of getting weed control in between. So this is another method that they could use when it comes to weed control. So it's compatible with organic farming. It's more suitable for certain geographical areas compared to solarization. So with solarization, you need like probably 30 or 30 plus days of 90 plus degrees to get that effect. But with biosolarization, you cut it down to about 10 or 2 weeks, or 10 to 14 days basically. And you don't need as high temperatures as in solarization. So that's what kind of makes it, really suitable for the East Coast, because solarization is mainly stuff that could be done out in the West Coast, out in California, Arizona, and those types of places. It's eco-friendly. And also it can be used with other weed management techniques. Again, integrated weed management. You could use biosolarization within the row, use cover crops between the row or whatever else between the row. And, that's basically, like I said earlier, integrating different approaches when it comes to solving one problem. And also we found that it may contribute to soil fertility. And there's a big question there, because we did some analysis on our pumice, and we found that it had good, especially the grape, it had good amounts of nitrogen in it, but we haven't, tested to see, if it's available or if the plant has been picking it up, but it may contribute to soil fertility. So with this study, our objectives were to develop a novel practice that vegetable farmers can utilize to manage multiple crop pests concurrently. And again, like I said, with all our studies, we have insect aspect and also a weed aspect. And also we're looking at evaluating the fruit-based biosolarization with living mulch, strip till system, and combined, and a strip till system by itself, and also combined to see how they could manipulate insect and weeds. So if we look at our treatments, so again, this was just a randomized, complete, simple design. We have 4 different treatments. We have a living mulch treatment. We have a living mulch no-till treatment. We have a solarized treatment, or like a green manure treatment. And again, further along, I'll explain how those treatments were prepared. And also we have a biosolarization or living mulch solarized treatment. So with this study, and with a lot of our studies, since we're working with cover crops, we have 2 preparation periods. So we have a fall prep, and also we have a spring prep. So with our fall prep, in our living mulch solarized, and our living mulch treatments, we had a mixture of red clover and rye, which we planted at 6-inch row spacings. But when it came to the living mulch no-till plots, we had a little different design for that plot. So we had red clover and rye, and we seeded them in separate rows. So if we look at this little schematic here, we have the rye, which is in the black, and then we have rows of red clover, which is in red. And the reason for planting them in alternate rows like that is because what we would do, and again, I'll explain it a little further along, what we would do is with the rye, we would come in, well, we'd basically roller crimp the whole row, and we'd plant within the rye row with a no-till planter, basically. And what would happen with the red clover is that it would eventually come back, and it would give us that living mulch that would control weeds between the rows. So for our spring prep with our living mulch treatments, we roller crimp the entire plot to terminate the rye. And the intra row or between row, within row areas, we strip tilled prior to eggplant transplant. And eggplant is our test crop for this study, for this year. With the living mulch no-till treatments, the rye was terminated with the roller crimper, and that's what I just explained earlier. And that would also temporarily stunt the red clover growth between the row, but eventually it would come back later on in the season. With the solarized treatments, the entire plots, we mowed and we rotivated it, and then we laid down the plastic and the drip tape within the row. So just a little schematic here, a little process to kind of show you, kind of better explain how we do the living mulch solarized or the biosolarized plots. So in the spring, we would come in, we would mow everything. Then we'd strip till, lightly strip till in between where we're gonna plant. I think it's about 18-inch. We strip till that little 18-inch short, 18 to 20-inch area where we're gonna transplant. Then we put down our pumice we put down our pumice within the row, and then we incorporate it by rototilling it very shallow, probably about six inches. We get it in, rototill it. Then we lay down our plastic tarp, our clear tarp, to facilitate our biosolarization. We lay down our tarp, and also we lay down our drip tape. And the guys at the station, they were really good. They did all of this without disturbing the between, well, minimally disturbing the between the row areas and the clover that's in between there. And then after we laid the tarp, like I said, we turned the irrigation on, we let it flood, and then we let the sun do its work. Then after the 10 days, that's recommended. But like I said, this year, it so happened that we did our study right before we got our little heat wave, right? So we kind of extended ours to 14 days. Because we didn't really have those temperatures that we were looking for. And then a week after, we got a couple, probably 3 or 4, probably a whole week of 90+ degrees. But so after the biosolarization went on for 14 days, we take off the tarp, let the soil aerate for about a week, and then we transplanted our eggplant. So for data collection, our responses, we looked at cover crop biomass, we looked at soil temperature, we looked at also root knot nematode, and we take prior to treatment, we took samples first fruit and at final harvest. We also look at weed species ID and counts 2, 4, 6, and 9 weeks after transplant. We also looked at insects, natural enemies, epigeal predators. And finally, we looked at our crop growth development, and also we looked at yield. Well, we will look at yield. So like I said, I don't have any data to show you, but a big problem which I saw in those fields is yellow nutsedge. So I could tell you clearly that yellow nutsedge cannot be controlled by biosolarization. And that's mainly because, if you know anything about yellow nutsedge, it germinates mainly via tubers and nutlets, and not by seed. So biosolarization basically works at inactivating weed seed. So when we have vegetatively proper propagules, biosolarization unfortunately doesn't have any effect on those. So basically, instead of plastic for in-row weed control, maybe biosolarization can be, something that can be explored by organic farmers or any farmer, basically. Again, with organic farming, right now there's no residual organic herbicides; they're all contact herbicides. So, like I said, maybe biosolarization could be something that would give them, that initial weed control, that would, eventually give the crop enough time to come up and form that canopy and block off that soil, within the row, controlling those weeds, and then our living mulch on the outside, that cover crop would also control weeds between the row. So it's basically a technique. Again, it's compatible with organic farming. It can be used with other weed management methods, inter-row, integrated weed management, but it's not effective on nutsedge. And so, yeah. But what I also found was that the field we used was under organic, for a while, and they haven't done much. They hasn't done any deep tillage on that field. So that could also contributed to the amount of nutsedge we saw in that field. But again, like I said, it's the first year of it. We'll switch out to another field next year and see what goes on there. But it's not very effective on nutsedge. So with that, I'll take any questions.
We have a question from Laura Hansberger. What were the dates the plastic was in range, and what was the under plastic temperature range?
So for the dates we put down, the plastic was, I would say, um it was like it was like mid-June. Again, I'm sorry I didn't put those dates, and it was about mid-June. The under plastic, we looked at I can't remember off my head the temperatures under the plastic, but it was higher. Well, that's kind of expected, but what wasn't expected is that it was higher because we had the solarized, which was just we didn't have the Palmas, but with the Palmas, we got a little higher temperatures. Like I said, I haven't analyzed it to see if those temperatures, if it's a significant difference, but we had a little higher temperature under this in the biosolarized versus the solarized. Now those numbers, I really can't remember.
Great. And don't have any other questions just yet, but if you have any questions, I know that Dwayne has a couple more slides with some conclusions. So we can see. Okay. All right. Well, we're going to move on, and we have a couple of questions for you before we finish. So let me open a poll. Hold on a second. There we go. Okay. So there, you should see a poll up on your screen with just 3 very quick questions. If you could answer those for us, that would be absolutely wonderful. All right, I'm going to end the poll and share the results with you. So we have people who are primarily somewhat and very knowledgeable and slightly about biosolarization. And somewhat knowledgeable and slightly knowledgeable about using cover crops between plastic rows. And there's a question here about IPM-related collaboration. Folks are somewhat aware and very aware, which is good to know. And how likely are you to increase your collaboration after today? That's a wide range of answers right there. How likely are you to increase your implementation of IPM? Moderately and very likely. We're glad to see that. And how likely are you to increase your implementation of integrated weed management? And we've got some really nice answers there. We're glad to hear it's been effective. And I know that Dwayne would. Oh, I'm sorry. I don't think I shared the results with you. So
That's fine. That's
sorry.
fine.
And then I know Dwayne wants to do some acknowledgements, and I have a couple of slides coming up too.
Yeah, so just wanted to acknowledge the funding source. Like I said, these are both NIFA funded projects. Also, my collaborators and PIs on here: Kurt Vollmer, Thierry Benson, Carl and Leslie, Kuni Yang over at University of Hawaii, Christopher Simmons at UC Davis, and Cerruti Hooks. And I guess with that, I'd like to thank Jana for inviting me over to speak, and have a nice day.
Wonderful. And if you can slide the slides forward. We actually already did that piece.
Okay.
And then find a colleague. If you are interested in collaborating around IPM in the Northeast, we have this webpage you can go to where you can put on a profile of the kind of things you're interested in collaborating about. And you can also find collaborators. So I don't know if Dwayne has a profile up there, but I'm sure he will. And it's a good way to find people who are doing work, or if you're a farmer or producer that you might be interested in collaborating on a project such as this. And if you could go to the next slide, that would be great. The recording of this is going to be available at our website, and I will send you an email sometime next week when that is available for you to view. And next slide, please. All right. The Northeastern IPM Center is at Cornell University in Ithaca, New York, and Cornell is located on the traditional homelands of the Gayohone. The Gayohone are members of the Haudenosaunee Confederacy, an alliance of 6 sovereign nations in the historic and contemporary presence on this land. The Confederacy precedes the establishment of Cornell University, New York State, and the United States of America. We acknowledge the painful history of Gayohni dispossession and honor the ongoing connection to the Gayohni people, past and present, to these lands and waters. And this land acknowledgement has been reviewed and approved by the traditional Gayohni leadership. And oops, Daisy. I apologize, you got that there.
So okay.
Our funding is provided by NIFR, and we appreciate the funding that NIFR provides. And the next slide, please. And that might be it.
That's
okay.
it, yeah.
All right, great. I also want to mention, if you can take the slides down, that'd be great. I also want to mention that we are providing a series coming up this fall on diversity and equity and inclusion in IPM. And we have a really interesting slate of presentations coming up. And if you go to our website, we add them continuously. The next ones are going to be in October, and we also have some coming up in November and December, and we're scheduling some that will be added as well going into next year. And if you go to our website, you will see they're all on our homepage, and we hope that you will enjoy other presentations that we offer. And with that, I want to say thank you very much to everybody who has attended and asked your questions. And thank you, Dwayne, for your research, for all the education it's taken for you to get here, and for your time and generosity of spirit and heart in sharing your work with us. So thank you very much.
No, thank you. Thank you, guys. Thanks.
Okay. All right. Bye-bye.
Bye.